Hi everyone, you're welcome back to Easy Science channel to learn about physics advanced level Excel past papers. In my videos, my aim is to make the learner to be more clearer, to write to the point in the given time and understanding the question. In my videos, I'm going to show you how it can be done so that at the end of my videos, you can try out what we have learned. By the way, if you are new to my channel, please remember to subscribe my channel and ring the bell so that you don't miss out any of my future videos. Okay, let's begin. Today I am going to discuss IL Physics WPH 1301 2021 Part 2 of the Unit 3. Shall we start with the first question? And it is actually not the first question, it is question number 3 of the paper. I have done question number 1 and question number 2 in my part 1 video. Okay, so let's begin. Question number 3. A student took measurements to plot a force extension graph for a rubber band. So you must understand what we are going to do. We are going to plot a force extension graph. That's what I have highlighted, all the important points for you to understand. So part A, describe a method he could have used to take the measurements. Your answer should include a diagram. So I have drawn clearly, and it's everything there what you want about the diagram. Okay, so first see, rubber band is attached by a clip. Free end of the rubber band is attached to the slotted mass hanger. It's hanging. Obviously there should be a ruler and meter ruler. It is attached to there's a horizontal bench over there. You have to fix everything on the bench, and there's a stand and clamp. So we have to have a set square to make the meter ruler in a vertical position. After that, label the diagram and you have to describe the experiment. So I have labeled everything. Okay, stand and clamp, meter ruler, rubber band, slotted mass hanger, set square and horizontal bench, everything. So now how to describe, this is a typical question. Now we are using a rubber band to see the extension. So we must write step by step what you are going to do. So here they are giving 5 marks. Yes, so you have to have 5 points to get 5 marks. Okay, so now first we must do is the student should measure the original length of the rubber band. We have to mention it is L0 for easy calculation, using a meter ruler which is placed vertically on the bench using a set square. So in one line you have written everything. Then you have to start adding masses of 5G. So onto a slotted mass hanger and one at a time, and measure the new length L1, L2, L3 so on. Hence the extension of the rubber band you can find. Okay, I'll put S over here. Okay, so hence the extension of the rubber band you can measure. So if you know the new length, you can subtract from L naught and can find the extension. That is also written in one line. So next what I'm going to do, the procedure in the second step must be repeated. This has to be repeated at least 5 times to get what? To get the mean value. Why we want mean value? To get our calculation to be more accurate. Okay, so you have to have the readings by repeating. Okay, so now fourth part is, next point is, during measurement taking you have to make sure that your eye level is perpendicular to the reading on the ruler. Why? To avoid parallax error. You all know that if you measure, if you keep your eye in a angle, so at an angle, then what will happen? You will look into that angle and you are getting wrong measurements. So to avoid parallax error, you have to uh, keep your eye level perpendicular to the reading. And finally, the student can calculate the force by using equation W equals mg and extension by using new length minus initial length. So you have more than minimum 5 readings you are going to repeat for the for this experiment. Okay, so now any sometimes they might ask you, write one precaution. I have given here. When you are doing this experiment, we have to be very careful about ourselves, right? So therefore, I mentioned the precaution handling heavy masses. So the student should make sure that his feet are not directly under the masses, because the rubber band might break off, causing the masses to fall onto your feet. So you have to be very careful. That is very common precaution you can write. Okay, so then we will move on to B part of the question. The student measured the extension as he was loading and unloading the rubber band. The graph shows his results. So actually I have done my working over here. Okay, it is a typical question. They will give you something, a graph. There you have to find the area. So I will teach you easy way to get the accurate area. You have to divide into big squares. So there you can find the area. So if you are taking this big square, you can find the area 7 minus 6, and this length is actually is going to be 0 0.20 minus 0.15 or 0.25 minus 0.20, you will find it is 0.05. So area of one big box you can find, and small boxes, 4 small boxes will give you one box. So I calculated this and I found 7 big boxes and 21 of quarter boxes. So you can turn into big boxes by dividing by, now quarter boxes 21 means you have to divide by 4, right? It is approximately 5 and 1 quarter. So like that you can calculate how many big boxes. Now I will tell you then how are you going to calculate the remaining parts? You make quarter. So now you go and see. Now here I will teach you one. This small square box, to fulfill you have to have 1 2 3 4 5 6 approximately 7.5. So you go somewhere inside and cut 7.5 and make this box as a quarter. Then you can add 1/4. The the outside of the square you cancel out with inside of the square. So it is balanced, then you can count as one small square. So likewise you have to practice this by your own. Okay, so I just wrote like this, and this is the easiest and way to get an accurate approximation. Okay, so I found the total boxes as 19.5. So you also can find maybe 19. It's okay. So length of one box I have calculated. Area of one box length into breadth. It is Newton meters. Always I'm advising you to write the units. So area of 19.5 boxes will be 19.5 into 1 into 0.5. It is coming as joule. So energy transferred as internal energy 0.98. Why I am going to give two decimals? Because our paper is given for two decimals. So I am telling again and again. Then you have to work it for three decimals. And you round it off to two decimals. So your energy transfer is going to be 0.98 joule. You know, energy transferred to the internal energy. When you read this, you have to underline. That is the question. What do you mean by that? You have to find the area between loading and unloading curves. Okay? So, uh, with this, our part B is going to be over, and question 3 is done. So we'll move on to question 4. I hope question number 3 is clear for you, and we'll move on to question 4. So now see question 4. A student measured a potential difference using an analog voltmeter. Okay, so this is the analog voltmeter. So calculate the percentage uncertainty in the measurement of potential difference. So you know, first we are asking potential uncertainty. So you have to think for a formula. Where did you learn percentage uncertainty? So everyone knows percentage uncertainty is all about absolute uncertainty divided by measured value into 100. Okay, so first we need to find the smallest measurement given in the scale, that is the resolution. Now see, it is 0.5. So that is the smallest measurement given in the scale. Okay, so the resolution here is 0.5, reading is 10.5. This is 11, it is 10.5. So uncertainty of the measurement delta V will be half of the resolution, that is 0.25. So then uncertainty will be, absolute uncertainty will be half of the measurement. So you put 0.25 and the reading, and you multiply by 100, you get 2.38, and it is given also for 2 decimal you have to give. So you work it out for 2 significant. It is given for 2 significant, so you work it out for 2 significant. So you are getting 2.4 as percentage uncertainty. Okay, so we'll move on to part B. The student could use a digital multimeter. This is analog, previous one. This is analog. You have to read and get their measurements. But in digital, it is there. It is visible in the screen. So now the student is using a digital multimeter. Okay. So now discuss the advantages of choosing the digital multimeter to measure the potential difference. So now you have to discuss advantages. So what are the advantages of having digital? You will never get the parallax error. Okay. And the other thing is here it is resolution is up to 2 decimal. But analog we had only 1 decimal. So you can write those. So what are you going to write? You have to write nicely. There will be no parallax error if we use a digital multimeter since it is a screen reading. So you have written everything in one line. Then the digital multimeter has high resolution up to 2 decimals, which is 0.01 volt, compared to the resolution of the analog meter, which is 0.5 V. So the percentage uncertainty will be reduced here. So those are the advantages. Okay. Now we will move on to question number 5. A student investigated how changing the temperature of a copper wire affects the resistance of the wire. He placed a coil of the copper wire into the beaker of hot water as shown. The temperature of the wire was measured using a thermometer with a resolution of degree 1 Celsius. Okay. The resistance of the wire was measured using an ohm meter with a resolution of 0.001 ohm. Okay, everything given in the diagram. So what they want? The student recorded corresponding values for the temperature of the water and the resistance of the water as the water cooled. The results are shown and they are giving the results. Now when you get the results, you have to be very careful. There can be anomalous and there can be so many mistakes while doing the experiments. So criticize these results means you have to say something about the results, maybe mistake, anything you can criticize. You have to give your idea about this. Okay. So what you can see, temperature line and resistance when you see the data. You will at once find, okay, the significant figures are not equal. Okay, this is given like here 3 significant, here 2 significant, here 3, again 2, again 3. Okay, there is no consistency in significant figures. And when you go to temperature line, that section, now 69 to 62, you have to take always, you have to take the difference. 69 to 62, you get 7 degrees difference. When you come to 62 to 55, 55 to 38, it is 13. Okay, so there's a huge jump from 55 to 38 when temperature changes from 38 to 55. So it is also not consistent. It doesn't follow any pattern. So what you can say? These results are not very reliable. That is the conclusion we can come after recording the results. So you have to write that in a point form. So you write there is inconsistent interval of temperature measurement, inconsistent intervals, and also there is inconsistent number of significant figures in resistance measurement, and there is no regular pattern. There is a huge gap between 55 to 38. You can write. Okay. Okay. So now B part. Plot a graph of resistance on the y-axis against the temperature of the x-axis. Okay. So they have given no. I just brought forward this table for you to understand. Now you have to plot nicely. Okay. When you are plotting, I'm always telling put a light cross without putting a dot. Okay. You have to do that. You have to put a cross. Here I have put a cross, and after marking, draw the best fit line. You take a graph paper. Without looking at this my graph, you draw. Follow my idea and draw the graph and draw the best fit line and do your calculation and see whether my calculations are equal to your calculation. It's the same. Okay, so I have written everything, and you know I have to get 3 decimal points. I have to get 2 decimal. So if you want to get 3 decimal points, make 1 1 and make 10 squares in between. So it is very easy to get the third decimal point, because 0.32 to 0.33 there is small 10 squares that will denote the last third decimal place. So I'll advise you that method for you to follow. So that is that side, and this side, your x-axis, we have to go until 70. So you can start from 0 and you can go on. But here you don't need to start from 0, because your first measurement is something like 200.294. So you can start somewhere not from 0.29. You can start somewhere before that, maybe 0.26 or 0.25. So this line is first, because I am marking 0.27, so it is this should be 0.26, and that's all about the graph plotting, and we'll move on to next part. The relationship between the temperatures T and the resistance R of the copper wire is given by this. R naught is the resistance of the wire at 0 degrees, and alpha is the temperature coefficient of resistance. Determine R naught and alpha. I want to give you an advice. Normally, the graph, you are getting unit 3, last question. It is almost y equals mx plus c. So when you get the equation of them, you have to turn into y equals mx plus c. You have to see whether m should be a number, c should be a number. Okay, it is fixed. Yes, r naught is fixed, and alpha r naught also. So what are the variables r and t? So you can make this equation r equals alpha r naught t plus r naught. You can rearrange in the form of y equals mx plus c. If you know, then you know the gradient is going to be alpha r naught, where r naught can be get from your graph when you extrapolate your best fit graph. I have done, and maybe it should be here. You have to make sure your line is exactly extending. Your best fit line is exactly extending to your y-axis, because I want R naught. This is the point. So that's what I told you. You have to draw your graph and do accordingly and find R naught. Maybe you also will get the same answer. Okay, maybe you will get 271 or 265. I'll make it 265 because when I draw I got 265. Okay, but now in my graph the line was little twisted and it says like that. So you can, I'm advising you to do, okay, you to do everything, and you have to practice. Don't go to the exam hall to practice everything. You have to practice at home, and you have to be very sure on your measurements. Okay, so it is something like that, 265. Okay, so you have to go back to the graph. So gradient, you know, it is alpha R naught, so you can calculate. R naught you can take like that. Then you know gradient is always y2 minus y1, x2 minus x1. All math students they know, and other students also. I'm telling, it is tan theta, and you have to have tan theta means the angle, and you have to angle here. That is, gradient is going to be this length, y length, divided by x length. So y length, it is not starting from 0, then you have to get the difference. So this coordinate, y coordinate, minus this y coordinate will give you the difference, and this x coordinate minus this x coordinate will give you this length. So tan theta according to Pythagoras is opposite over adjacent. So in physics we are telling our tan theta, that means angle to the horizontal side is equivalent to our gradient of the line. So thinking that way for all the students, I wrote this. M is going to be y difference and x difference. So then you can calculate and get the alpha and R naught from the graph. Okay, it is my graph. It is going to be 265. Okay, because these questions, no need to keep the accurate value because it is best fit graph. So there's a range, they are checking your answer. If you are within the range, they will give full marks. So don't worry about the answers in these best fit graphs. Okay, now we'll move on to, okay, we have come to the end. So that will be the end of the part 2 of the unit 3. I think all of you understand very well. Thank you very much. See you in next videos. Until such time, study well. Have a nice day.